In this example, we're going to use data from 2012 GSS to make calculations using the normal distribution. So in this set of questions, we're told that we have 1,278 cases, and we're told that they have some data on the number of words they guessed correctly on a vocabulary test, which is captured in a variable called word sum. Now, in our sample, we find that on average, people guessed about 6 words correctly with a standard deviation of 2 words. We're also told that the distribution of the number of correctly answered words follows a normal distribution. And so what we're going to do is we're going to basically use z-score transformations to take raw scores and turn them into standardized units or z-scores, finding areas corresponding to those z-scores to answer a variety of different questions. So our first question is, what proportion of people guessed 8 words or fewer correctly? And so what we're going to do is we're going to start with a diagram. And so our diagram basically shows the distribution of the correctly guessed words. And if we're interested in the number of people who guessed between 8 or fewer words correctly, our diagram is going to look like this. So we know that 6 is the mean, so 6 is in the middle of our distribution. 8 is above the mean. And so what we're interested in basically is the area between the mean and the z-score, between 8 and 6. But we're also interested in the area below 6, or the area corresponding to this area. So what we're going to do is we're going to separately calculate this area and then the area between 8 and 6. And that's going to, the areas together will basically be the entire area that we're looking for. That's the answer to this question. So we're going to look at this area and this area separately, add them together, and that the answer to the question will be that area. And so we're going to start by taking 8, and we're going to turn it into a z-score. And we do that by using the z-score formula. Remember, the z-score formula tells us to take the raw score, subtract the mean, y bar, and divide it by the standard deviation, s sub y. So in our case, 8 is our raw score, and we're going to ask how many standard deviation units is 8 away from the mean. So if we take 8 and subtract 6, the mean, divided by 2, the standard deviation, that gives us 2 in the numerator and 2 in the denominator. And so the ratio of those two is just 1. And so that tells us that 8 is 1 standard deviation above the mean. Well, now we have to find an area corresponding to the area between 8 and 6. And so that's going to be column B in our table. And so we're going to look up our z-score, 1, in column A of the table. And we're going to find the area corresponding to that z-score in column B, which shows us the area between the mean and the z-score. And that turns out to be 0.3413. And so if we round this, and if we express it as a percentage, that means about 34% of people scored between 6 and 8 correct words on the vocab test. Now, in order to answer the question, we're not quite finished. We still have to account for everybody who has less than 6 words correct on the vocab test, and that's this area. And so the entire area under the normal curve is 1. And because it's symmetrical, half the area is below the mean, half the area is above the mean. So that means that the area below the mean of 6 is 0.5. And so we're just going to add the area that we found between 6 and 8, 0.3413, to 0.5, and that'll give us the answer to this question. The value is going to come out to 0.8413. And so if we round it and express it as a percent, that tells us that 84% of people guess between 8 or fewer words correctly. Okay, in our second example, suppose we wanted to know what proportion of people got over 8 words correct. So that would be this area. So we're basically trying to figure out the area beyond the z-score this time. And we're going to approach this question the same way. We're going to take 8 and turn it into a z-score by subtracting the mean, 6, and dividing by 2, the standard deviation. Again, that gives us a z-score of 1. But this time, when we look up 1 in the standard normal table, we're not going to look for the area between the mean and the z-score, or column B. We're going to look for the area beyond the z-score, column C. And so for a z-score of 1, that's an area of 0.1587. In other words, that tells us that about 16% of people got 8 or more words correct. And so that's the answer to this question. Notice that if we take the area from the first question, 0.84, and add it to the area of the second question, 0.158, that comes out to a value of 1, or 100% of the area under the normal curve, because these two are basically complements. Okay, let's move on to a third example. Suppose now that we wanted to figure out how many people guessed between 5 and 8 words correctly on the vocab test. Here's our diagram. So notice that 5 is below the mean, while 8 is above the mean. And so we're going to have to do this in 2 steps. We're first going to have to find the area between 5 and 6, and then we're going to have to find the area between 6 and 8. And if we just add those two areas together, that's going to be the answer to our question. And so let's start with 5. We'll turn 5 into a z-score. So 5 minus the mean divided by the standard deviation is going to give us -1 in the numerator, 2 in the denominator. So that comes out to a z-score of -0.05. And that tells us that 5 is half a standard deviation below the mean. So if we wanted to figure out the area between 5 and 6, we have to look it up in the standard normal table. And we're going to look at column B, which is the area between the z-score. And so looking up -0.5 in the table is impossible because the standard normal table only shows positive z-scores. However, because the normal distribution is symmetrical, that basically means that areas below the mean correspond to areas above the mean. So all we have to do is look up the positive or the absolute value of our z-score to find the right answer. So if we take the absolute value of -0.5, that gives us positive 0.5. And so because it's symmetrical, we can use the positive equivalent of the z-score to get the correct answer. And so if we look up positive 0.5 in the table, the area between the mean and the z-score for that is 0.1915. In other words, about 19% got between 5 and 6 words correct on the vocab test. Okay, but we're only halfway done. So far we've only found half the area that we want. Now we have to find this area. And again, we just have to take 8, turn it into a z-score, and find the area between the mean and the z-score for 8. So we take 8, subtract the mean, divide by the standard deviation. That gives us a z-score of 1. We look that value up in their standard normal table in column A, and we find the corresponding area in column B, which is the area between the mean and the z-score. And as we've seen before, it's equal to 0.3413. And so we just add those two areas together, 0.1915 plus 0.3461, and we get a total area of 0.5376. So if we round that and express it as a percentage, that tells us that 54% of people guess between 5 and 8 words correctly. And that's the answer to our question. As a final example, suppose we wanted to know how many words somebody guessed correctly if that person was in the 85th percentile. Now to answer this question, we actually have to work backwards. We're going to have to solve for y in the z-score formula. But first we have to figure out what z-score corresponds to the 85th percentile. And in order to do that, we have to keep in mind that our table only shows half the area under the normal curve. And so we have to subtract out the areas below the mean because they're not accounted for in the table. And so if we take 0.85, our 85th percentile, and we subtract the area below the mean, or half the area under the normal curve, we're left with 0.35. So now what we're going to do is we're going to look that value up in column B of the table and find the corresponding z-score. So if we look at column B, the first one to have a value of 0.35 corresponds to a z-score of 1.04. And so we can plug that value into our z-score formula along with the mean of 6 and the standard deviation of 2, and we can solve for y. That'll be the answer to our question. That'll tell us how many people, how many words somebody got correct if they're in the 85th percentile. So we're just going to use some basic algebra here. So first we're going to get rid of this 2 in the denominator by multiplying each side by 2. That will cancel this 2, and that will give us 2 times 1.04, or 2.08, on the left side of our equality. It'll give us y minus 6 on the right side. To get rid of the 6, we're just going to add 6 to both sides. So 6 plus 2.08 gives us 8.08. Y minus 6 plus 6, notice that this cancels out, so we're just left with y. So y equals 8.08. That's the answer to our question. So if we basically round it, that means that a person in the 85th percentile guessed about 8 words correctly. In this example, we're going to use SPSS to look at the normal distribution in z-scores. And we're going to use data from the 2012 General Social Survey. Now, using SPSS in this fashion may not possibly be the best choice. There are sort of a limited number of things that we can do with z-scores in the normal distribution in SPSS. But there are nonetheless some variables that sort of naturally follow a normal distribution for which we can kind of get a better sense of what the z-score and the standard normal distribution actually is intuitively. And so one of those variables is something called word sum. And word sum basically is a variable that counts the number of correct answers that somebody got on a brief vocabulary test. So let's start by creating a histogram of this word sum variable. So if we go to Graphs, Legacy Dialogues, and then Histogram, we can select the word sum variable. And that's kind of near the end of the variable list. And then we can move it over here to where it says Variables. And we can click on OK. And SPSS will create a histogram of word sum. Now notice that it follows an approximately normal distribution. In fact, one thing that we can do with our graphs is to superimpose a normal curve on it. So again, if we go to Utilities, Graphs, Legacy Dialogues, Histogram, there's a little check mark we can put right here next to Display Normal Curve. And so if we click OK, notice that SPSS draws a new curve, and this time the curve has a superimposed normal distribution on it. And so notice the word sum approximately follows a normal distribution. And so the mean is about 6. There's very few people who get 0 correct. There's very few people who get more than about 10 correct. So most people are sort of in the middle range. And so notice that this variable follows an approximately normal distribution. Now in SPSS we can actually do some analysis and create a z-score variable. And so if we go up to Analyze, Descriptive Statistics, and Descriptives, let's pick our word sum variable again. So I'm going to scroll down and pick word sum, move it over here where it says Variables. One of the things that we can do is we can put a check mark next to where it says Save Standardized Variable Values as Variables. What this does is it's going to create a new variable that's a standardized version of word sum. And so basically, we're going to get the values of word sum listed in z-scores. So we'll click OK, and we should find that we have a new variable in our data set. Okay, and so how did it do this? Well, the output that it includes is some descriptive statistics. So notice that the mean of this variable word sum is 5.96, or close to 6, with a standard deviation of 2.051, so close to 2, right? And so what basically SPSS took each of the values of the original raw variable word sum, subtracted the mean, and divided by the standard deviation. And it created a standardized version of word sum. And so we can actually graph this new variable. So again, if we go up here to Graphs, Legacy Dialogues, and we'll make a histogram of it, it's going to be kind of at the end of our list. It's the last one. It's called Z word sum. And so we'll take word sum and we'll move it away. And then we'll go to that variable Z word sum. And again, we'll display this normal curve. Click on OK down here. So now notice that we have at the bottom, we have a histogram of this new variable. And notice that it too follows a normal distribution, right? So there's very few people who have values in either of the tails. Most of the distribution is sort of in the middle here, right? And the middle is around the value 0. In fact, if we scroll up just a little bit, here are the actual means and standard deviations that were calculated for this new variable that's expressed in z-scores. Now, this is kind of a weird measure. The mean here says that it's a value of negative 3.94 e negative 15. And what that means is basically it's scientific notation. That's the value negative 3.94 times 10 to the negative 15. So there's like 14 decimal points before the 3. And so basically this is SPSS way of saying that we have some very small value. And because of rounding error, it doesn't sum exactly to a mean of 0. But this is as close as it's going to get. So basically you could kind of see that as meaning that this is a value of 0. And notice the standard deviation is 1. And so what we've done here is basically we've taken the original word sum variable and we've changed it into a variable that follows a standard normal distribution. That is, a distribution that has a mean of 0 and a standard deviation of 1. And if we wanted to see how the original word sum variable compares to the new z-score version of the variable, we can go back to our original data set in the data view. And what we can do is we can kind of scroll over. And we can actually move the word sum variable, which is right up here. We can move this so that it's closer to the actual end of the data set where we have our z word sum variable. And so we're just going to kind of move it over. And we're going to continue moving it until we get to the end. And so here we have word sum side by side with the z-score value of word sum. And let's kind of scroll in and take a look at some of these. Now, negative 1 for the original variable word sum indicates a missing value. So that wasn't used in the creation of this z word sum variable, the z-score equivalent. So when you see -1, that just means a negative value. And notice that SPSS uses a dot to indicate that value is missing. But now look at the ones that are non-missing. So here's a value of 7 on word sum. So the standardized version is 0.5268614. And so that basically means that 7 is about a half of a standard deviation above the mean. Here's 9. 9 is about 1.5 standard deviations above the mean. 6 is about 0.3 standard deviations above the mean. 3 is less than the mean, right? So 3 is 1.4 standard deviations below the mean. That's a negative value. And so you can kind of see that what SPSS basically did was it standardized these values, turned them into z-scores, and these values tell you how far each of the raw values are from the center of the distribution, where the mean's located, expressed in terms of standard deviation units. And so that's kind of an interesting thing to look at when we're thinking about standardized variables. And so this new standardized variable follows a standard normal distribution with a mean of 0 and a standard deviation of 1. Each of its values are standardized units that tell you in z-scores how far away those values are from the middle of the distribution. Now we could also do something like this in PSPP. PSPP actually has some of the same capabilities. Unfortunately, the histograms are a little harder to make. But if we go to Analyze, Descriptive Statistics, and Descriptives, again, we can pick our word sum variable, and we can just move it over to where it says Variables. And when we can just put a check mark next to where it says Save z-scores of selected variables as new variables. And we can click OK. And PSPP will make a new variable that's equal to our word sum variable. And so again, if we just wanted to look maybe like the frequency distribution, we can go to Analyze, Descriptive Statistics, Frequencies, and that new variable should be in our data set. And it calls it z-score vocabulary test, z word sum. So the same thing that SPSS does. And again, if we click OK and we go to our output window, and we scroll in, we can basically see how this new variable looks in terms of z-scores, right? So we can see that there's not very many cases in the tails. Most of the cases are near 0, which is in the middle. You can see that the mean here effectively is 0. Standard deviation is 1. So this is a new variable that follows a standard normal distribution. These are standardized versions, z-score units, that were basically derived at by taking the value, the raw score, subtracting the mean, dividing by the standard deviation. That makes the new mean 0, the new standard deviation of 1. And thus, it's a standard normally distributed variable in this case.